So far, we've looked at using Pythagoras' theorem to find the longest side in every example. So every time we've done one of these questions, we've been using it in the form c squared equals a squared plus b squared. But Pythagoras' theorem can also be used to find one of the two shorter sides, so a or b. And to do that, instead of taking the two shorter sides and squaring them and adding them, we take the shorter side that we know and the hypotenuse, because to find a third side we need to know the other two, and we square them and take them away instead of squaring and adding them. So I've written here that we use a new formula, but it's not really, it's just an algebraic rearranging of the existing formula. So we say that a squared is equal to c squared minus b squared. Now, you don't get this version of the formula in the formula sheet. So you're going to have to make sure that you know when to use that one and that you've been able to remember it. I'm going to show you a couple of examples using this new formula. I say new in little quotation marks because it's not really new. One where it's nice whole numbers, and then one where we have to do a little bit of rounding. So the first example here is asking us to use Pythagoras' theorem to calculate the length of t millimeters. So first step is always, just like what we did before, to label the sides and then copy down our formula. So notice this time, this is the first example we've done where the side C is a length that we actually know. Before it was always C was X millimeters or Y kilometers or something like that. But notice how in this example, we already know this one, because instead of finding the longer side, we're working backwards to find one of the shorter sides. So I'm going to label the thing that I'm trying to find as A centimetres this time, and the other shorter side as B centimetres. So I'm going to copy down the formula, the one that we're using, which is a squared equals c squared minus b squared. Because it doesn't make sense. If I was to do 3 squared plus 5 squared and then square root it, I would get an answer that's bigger than both 3 and 5. And that can't be the case because we know that the hypotenuse has to be the longest side. So that's why we have to square and subtract rather than squaring and adding, because whatever our side is cannot be longer than 5. So instead of a squared, I'm going to write t squared, and then 5 squared minus 3 squared. So even though the question doesn't specify, I'm going to just do this without a calculator because the numbers are nice and easy. 5 squared is 25, and 3 squared is 9 because it's just 5 times 5 and 3 times 3. So that tells us that t squared is 16, and if t therefore is the square root of 16, then t is 4 millimeters. And I'm going to just explain to you now 2 ways that you would know straight away that you've done this question the wrong way about. So the first hint here that you had a wrong answer would be if you got a negative answer. So if for some reason you got a negative, then you would know that it was wrong. Because we're talking about lengths, and I couldn't ask you to go and measure a minus 4 centimetre line or a minus 12 metre line. That's impossible. You can't measure a negative length. So if you get an answer and it turns out to be negative, what you might have done is done 3 squared minus 5 squared. And if that's the case, then you'll be alerted straight away that it's wrong, and then you'll have to go back and fix it. Another clue there would be that your calculator won't let you take the square root of a negative. Then the second sign that you've made the mistake is if you get an answer that is bigger than the hypotenuse. So you cannot have, in a right angle triangle, a side that is longer than your hypotenuse C. Okay, it can't happen. So if you'd got an answer there that was 5.7 or 6 or something like that, then what you might have done is 5 squared plus 3 squared instead of taking it away. So there's 2 ways when we're doing the shorter side questions to just fact check your answer and say, well, does this answer make sense based on the question and based on the fact that we're talking about length, so things that you can measure, so the answer can't be a negative number. For this question here, the second example, we're going to use Pythagoras' theorem to calculate one of the shorter sides again. And it says we're rounding our answer to 1 decimal place. So a little clue here that the answer that we're going to get is probably not going to be a nice number. It's going to be a long decimal answer. So here is my right angle. I'm going to go across here and label this side as C. So again, in these examples, we know C, we know the hypotenuse, and we're going to have to work back to find something that we don't know, one of the shorter sides. So A in this case is Y and B is 12. I'm going to say A squared equals C squared minus B squared. We want to find A squared. I'm just going to replace A with Y. And then 14.5 squared minus 12 squared. So this isn't a question that we're going to be able to do without our calculators because the numbers just aren't nice enough. We won't be able to do 14.5 times 14.5. And a clue is that if it's got a kind of pointer in the question to round it to a certain number of decimal places, like this one does here, then chances are you're probably going to just use a calculator for it. So y squared, when you take 14.5 squared and 12 squared away from each other, comes out to be 66.25, which means y is the square root of 66.25. We're expecting a big long decimal answer. We get 8.1394 blah blah blah. And I'm going to round that to 8.1 because that's what the question asks us to round it to. The units are meters, so it's important to include your units. And I'm just going to clarify that I've rounded that to 1 decimal place.